vertical projectile motion in one dimension. Today we will discuss about the vertical projectile motion in one dimension. So when we're talking about vertical, we are talking about this line here. It goes from up to down, or from down to up. We are talking about this here. When we're talking about a projectile, we are talking about an object that moves under the influence of gravity. We do not have other forces like air resistance and those other forces. And motion, you're talking about the movement of an object. So vertical projectile motion, you're talking about the motion, the movement of a projectile vertically. And one dimension means that we are only focusing on one dimension. You're not focusing on projectiles where those objects are fired like at an angle like this here. We are not focusing on projectiles where they are fired at this angle also, and we are only focusing about one dimension, only one straight line. With that being said, let me give an example of this projectile motion here. Let's say we throw a ball upwards with a certain velocity. What happens to that velocity when the object is going up? Does the velocity increase or does the velocity decrease, and why? The correct answer to that question is as the projectile goes up, its velocity decreases. And why does it decrease? It's because of gravity. The object is going up, but gravity wants it down. That's why it loses power when it is going up, and eventually it will come to a stop somewhere and then return back to where it was thrown. Like if you are holding a ball and you throw it upwards, it will go up, and it will there will be a point where it stops, and then it starts falling back down to you. And I give an example here. Let me remove this. Let's say we throw a ball upwards with a speed of, velocity of 39.2 meters per second. When I throw that ball there, I threw it with it left my hand with a velocity of 39.2 meters per second. After 1 second, it had a velocity of 29.6 meters per second. 29.4 meters per second. After 3 seconds, it has a velocity of 19.6 meters per second. After the third second, it had a velocity of 9.8 meters per second. And when it reaches its maximum height, it has a velocity of 0. This is where it reaches its maximum height. Maximum height. After reaching its maximum height, it has to fall down again, because according to the law of gravity, anything that goes up must come down, like this. Anything that goes up must come down, and when it comes down, it starts having the same velocities as before, but in opposite directions. That's why here I put negative. Like I always say, negative does not mean it is less in physics. It means that it is in another direction. It has minus 9.8 meters per second. After 2 seconds, it has minus 19.6 meters per second. After 3 seconds, it has a velocity of minus 29.4 meters per second. After 4 seconds, it has a velocity of 39.2 meters per second. What is happening here? We can see that the velocity changes by 9.8 meters per second every second. It's because of the gravitational constant. So what is a gravitational constant? Let me read it here. And I hope you can see there. It says acceleration due to gravity. The acceleration of a falling object as a result of the attractive gravitational force of the Earth in the absence of air resistance. So when there is no air resistance, gravitational acceleration is 9.8 meters per second downwards. So the velocity here changes by 9.8. Let me write it here. The velocity changes by 9.8 meters per second Yes, it changes by 9.8 meters per second. What does this mean here? And remember that meters per second can be written as meters over second. If you did the laws of exponents, you will know what I'm talking about here. And when we times this by second, by 1 over second, we get it's m times 1, which is equals to m over s times s, which is second squared. Someone is wondering what I'm doing here. I'm gonna show you that in a second. So we get this here. We get 9.8 meters per second squared. Meters per second to the power negative 2 is the same as this here. So what does this mean here? It means that the velocity of this object changes in every 9.8, it changes by 9.8 meters per second every second. That's why this here, that's what acceleration tells us. Acceleration tells us that there is a change in velocity. So it's 9.8 meters per second every second. We can see here it was 39.2 minus 9.8, it goes to 19.6, minus 9.8, it goes to 19.6, minus 9.8, it goes to 9.8, minus 9.8, it goes to 0. This is where it reaches its maximum height, and then it goes back, having the same velocities here, but in opposite direction. So the velocity that this ball here, the velocity that the ball leaves your hand with is the same velocity that it will return to your hand, if you do not remove the hand, of course. And what else can we discuss here? Oh, and the time. Let's talk about the time. The time that this ball leaves your hand to reach its maximum height is the same time to go from its maximum height to your hand again. So if it took 4 seconds to go there, then you take another 4 seconds to go down. So it's 4 seconds up, 4 seconds down. So the total time for the entire motion is 8 seconds. So we measure time in seconds. So let's discuss the 4 equations of motion. Before we even go further, I want to introduce these terms here. I hope they are visible there. We have a free fall and a projectile. So what is the difference between them? A free fall is the motion of an object under the influence of gravity only. So when you release something from a height, and that something will experience a free fall. Like this, I was holding this pen, I let it go, and it undergoes free fall. And when we're talking about projectile, we are talking about an object that we give an initial velocity and then it experiences free fall. I hope these 2 terms here are clear. And we have equations of motion, which I will introduce here. They are in your formula sheet. The first one says Vf is equals to Vi plus G times change in T. You will use this equation a lot. if formula a lot, you'll use this one, you'll use this one. This one, most people don't use it, but it works just fine. It's just that it wasn't that necessary for them to introduce this formula. But trust me, it works just like all other formulas, but we're not going to use it most of the times. And we said that G here is constant, is 9.8 meters per second downwards. Just by knowing this, you can earn yourself 2 marks in an exam, just by knowing this only, because they will ask you to give them this. They will ask you what is the gravitational acceleration on the ball when it is at its maximum height. So it's 9.8 meters per second downwards. Always, gravity never acts upwards, it always acts downwards. So here at every point on this time symmetry here, the gravitational acceleration is 9.8. It's 9.8 here, 9.8 here. It's always 9.8, and when this ball is going up is negative 9.8. When this ball is going down is positive 9.8. We'll talk about that in just a few minutes. And then let's look at here. The most common mistake that most students make is with direction. You can see how many times I wrote direction here. I want to clarify this here. Direction is very, very important when it comes to this vertical projectile motion. So let's say here we are throwing a ball upwards. We talked about this. When you throw a ball upwards, what happens to its speed? Its speed will decrease because of the force of gravity. And when that ball falls back, its speed starts to increase in the negative direction. Why does it increase? It's because of gravity. Gravity acts downwards and the speed is also going downwards. So that's why the speed increases when it is coming back and decreases when it's going down. Going up. Sorry about that. So when a ball is going upwards, let's choose upwards as positive. So it will have a positive initial velocity. It will have a positive final velocity. It will have a negative gravity. Why a negative gravity? Because it is going up, but gravity acts downwards. So gravity acts against the motion of this projectile there. That's why it's negative. And we have a change in y, which we call it a displacement. A displacement will be positive because the projectile is going up and the displacement is also up. So it becomes positive. The change in time is always positive. We can never have a negative time, because a negative time tells us that we can go back in time, which we wish to do, but we cannot do. We cannot travel back in time. So change in time is always positive. And then what if we choose downwards as positive? Our initial velocity is upwards and we choose downwards as positive too. So we will have a negative initial velocity. And let's say the final velocity is upwards and we choose a positive direction as downwards, so we will have a negative final velocity. Gravity goes downwards and we choose downwards as positive, so we will have a positive gravity. And displacement is going up, but we chose downwards as positive, so it has a positive displacement. And we have a change in time, which is always positive. It can never be negative. I explained why. So we can see that everything here changes signs except for change in time. If it was positive here, then it becomes negative here. If it is negative here, it becomes positive here. So I hope you can understand the main importance of choosing direction. In the next video, we will do just one example on how to, well, I don't think I will do it in the next video. Let me just do it now to see how far we can go with this. and I don't think I have my calculator for now, but yeah, let's do it. And let me check my camera if it's showing well. Okay, it looks like we are in the 15th minute. I didn't want to make this video long, so I hope you can see there. It says Sipho throws a stone vertically downwards from the top of a 30-meter bridge through a surface of water below. Ignore the effects of air resistance. So what's happening here is that Sipho here, you can see Sipho there, he throws this ball here downwards. When he throws this ball downwards, this ball will experience a free fall. What is a free fall? A free fall is a motion of an object under the influence of gravity only. And what will happen? Of course, this stone here will hit the surface of water with a certain velocity. We want the velocity just before it hits the water. We call it the final velocity, just before it hits the water. And let's see what they're saying here. I hope you let me see the camera there. Okay, it's showing there. And it says here, the stone hits the surface of the water with a velocity of 29.49 meters per second. They say calculate the speed with which the stone hit the water with, calculate the speed that the stone was thrown with, or the speed that Sipho threw the stone with, in other words. So we are looking for the initial speed of this stone. So which equation can we use? Of course we can, I'm looking for where I can write, and let me write here. And we have that V final squared is equals to V initial squared plus 2G change in Y. We have change in Y, and we have VF squared. So VF squared is 24.49 squared is equals to V initial squared, which is what we are looking for, plus 2. I choose downwards as positive, so gravity will be positive 9.8, and my displacement will be positive 8. So I will move this to the other side. It will become 24.49 squared minus 2 into 9.8 times 8. I get a value of 11.46, and yeah, I get a value of 11.46. Let's take the square root of that. Square root of answer, it gives me a value of 3.43. So the initial velocity is 3.43 meters per second. So this is the speed that Sipho threw the stone with initially. So what is the next question? The next question is, calculate the time the stone was in free fall before falling into the water. So we want the total time of the entire motion from here through here. So how can we calculate that time? I think we have everything here. We have the final speed and then the time. So I mean the final speed and the initial speed. So we can say V final is equals to V initial plus G change in t. We want change in t, so we have final of 24,49 is equals to 3,43 plus 9.8 change in t. So I'm going to bring this 3,43 to the other side. It becomes 24.49 minus 3.43 over 9.8. I divide by this 9.8, I get an answer of 2,15 second, 2,15 seconds rather. And this is how we do this projectile questions, and I believe I will see you in the next video. For now, take care.